At first glance, this looks completely impossible. We're given just a few pieces of information and somehow we're supposed to find the side of the square. But there's a hidden connection here that makes everything work. As you can see, I have started this video a little bit different than before. Here I have shared with you the mail from my subscriber Marian, who wanted me to solve this problem. And since I was asked a couple of times to show my thought process before making the animation, let me quickly walk you through how I approach a problem like this. So first, I will always open this PDF file in one really awesome program, which is called UPDF. And let me show you how this whole process works. First, I will open this PDF file in UPDF. Then I will enable an OCR functionality so that UPDF can recognize the text and that we can manipulate it. Also, at the top of this interface, you can see that we have a lot of options at our hands. We can highlight the text, we can add the text or comment or a sticky note, or we can draw with a pencil or the shapes directly into our PDF file and manipulate it, which is quite handy. Of course, I'm currently using a PC, and if you are using an iPad, this experience is going to be even smoother for you. Alright, so now let me show you the thought process. So first I'm going to use this highlighter to see which part of the text is important. First important thing is that ABCD is a square. Then we can notice that the segment DF has the length of 6, and finally that the triangle FEC has the area of 26. Also important is that line CF is perpendicular to the line DE. Alright, so now I have all necessary information, and now let's go back to our sketch. I can clearly see that the line DF has the length of 6, but I don't know anything about the segment FE. So I can first label the length of the segment FE as B, for example. Alright, so now I can see that I have this really nice right angle triangle FEC. And let me use the polygon tool here. I will use the green color and set the opacity down like this. Now I can see that the side FC actually represents the height of this triangle, so I can label it as H. Now I can easily make the connection between B and H using the area of this triangle. And this is actually going to be my step 1 of the process. Great. So now we know that we are looking for the side of the square, so let's label it as S, and let's also label this side on the top of the square, or the side DC. Now here you can notice that I can make another connection between S and H by using this triangle DFC. And this connection is actually going to be my step 2 of the process. So finally I have 2 unknowns and only 1 equation. So I need to make another equation, and I can do this easily by using this right angle triangle ADE. Alright, and let me just set its color to red, and this triangle is going to be similar to our blue triangle DFC. And let's say that this is going to be my step 3 of the process. And there you go, this is how I make my draft before I start animating the video. And I can now save this, and here this is the great thing about UPDF, you can even use their AI tool as a help. It supports GPT-5, which is great, and you can convert this in multiple formats. For example, I always like to convert it in image, and from here I will continue on with an animation. Also, this tool, UPDF, is great because it is a cross-platform tool. It works on Windows, Mac, iOS, and Android at the same time, which makes it a really, really awesome tool. So, if you guys want to check it out, I will leave the links down in the description below. both for UPDF Editor 2.5 and for UPDF AI. So now when I have this draft, I will continue on with my animation process, and let's go ahead and continue on with it to solve our problem. Here you can see our original sketch, and I have already labeled the side of the square as S. Now let's label all the vertices of the square the same way as on the sketch as A, B, C, D, and also the bottom intersection as E and the middle one as F. Now let's do this as in our draft. First, let's label the segment EF as B and the segment FC as the height of this right-angled triangle as H. Now, since our green triangle is a right-angled triangle, we can make our first connection between B and H, since the area of any right-angled triangle equals to the half of the product of its base and height. And we already know that the area of this triangle is 26. So we're going to simplify this by multiplying with 2 and get the following. From here, we can write this down in terms of B and get that B equals 52 over H. Great, so now let's take a look at our blue triangle. Remember from the draft, the triangle DFC. This is again right-angled triangle, and we can use the Pythagorean theorem to try to connect the value of H with the side of the square DC. So the hypotenuse DC squared is equal to the leg DF squared plus the leg FC squared. And we're going to substitute the values from our sketch. Now we're going to work through this a little bit and get that DC, which is the side of the square, actually equals to the square root of the quantity of 36 plus H squared. Now remember, this is also the side DA of our square, so we're just going to write this value down on DA as well. Alright, so let's clear our image a little bit, and now let's take a look at the blue triangle DFC. We can label the acute angle at the point D as alpha, and the acute angle at the point C as beta. Now, since those two angles are acute angles at the right angle triangle, this means that their sum must be equal to 90 degrees. Now, if you take a look at the overall angle at the point D, this angle must be 90-degree angle, since the angle at the point D is the angle of the square. And this implies that the remaining acute angle at the point D, or the angle ADE if you like, must have the value of beta, since alpha plus beta equals 90 degrees. Now, if you take a look at the red triangle from our draft, the triangle AED, this is also the right angle triangle. And this means that the remaining angle at the point E must be angle alpha once again. Those two triangles, the red and the blue one, are actually similar triangles, since both of them share the same interior angles. So let's isolate them. First we will isolate our red triangle, and we will write down the value of its height and its hypotenuse. And we will do the same for the blue triangle, but I will reorient it the same way as the red one, so you can follow along more easily. And we will also label the height and the hypotenuse of the blue triangle as well. Now we will use the rule of similarity on those two triangles, and we can say that the relation between their heights must be equal to the relation between their hypotenuse. And we're going to use this equation. But before we do that, we will just implement the value of b into our equation. And in this way, we will only have one unknown value, h. Now let's solve this one. First, we're going to cross-multiply it, and then we're going to get rid of the square root on the left side, and we're just going to do some multiplications on the right. And finally, if we put all our terms on the left side of the equation, we're going to be left with this really nice quadratic equation. Now you can solve this one in multiple ways, but I will use my favorite one, the quadratic formula. Now, as a quick reminder, if you have a quadratic equation, in the form of ax squared plus bx plus c that equals 0, you can use the following quadratic formula. From our quadratic equation, you can see that a equals 1, b equals minus 6, and c equals minus 16. So we're just going to implement those values into our quadratic formula and get the following. Now we're just going to simplify things underneath the square root, and finally we will get that the values for h must be 6 plus 10 over 2, which is 8, and 6 minus 10 over 2, which is minus 2. But remember, h represents the length of the line FC, and this length cannot have a negative value. So it makes no sense for h to have the value of minus 2. So the only possible solution for h is that h equals 8. Now, remember, we're looking for the side of our square, and we have labeled it as S, but this side equals to the side AD. So this means that S equals square root of 36 plus h squared, and we're just going to substitute the h for 8 and get the following. Now we're going to work through this and get that S equals square root of 100, which means that the side of our square has the length of 10, and this is our solution. Well, I really hope you guys enjoyed this video and that you enjoyed the thought process behind the curtains. If you did, do not hesitate to leave a like or subscribe to the channel for more content like this in the future. Of course, if you found another way to solve this problem, please write it down in the comment section below. I always love to see your solutions. And until next time, see you guys and take care.